Section 2.3, we're still going to be solving linear equations. We're going to be combining both methods from the previous sections. So the general steps for solving linear equations here, we're going to work with both sides of the equal sign separately and simplify them. That might be, we might have to distribute, combine like terms to simplify them. Then we're going to isolate the variable terms on one side of the equation and the constant terms on the other side of the equation using that addition property. And then we're going to isolate the variable using the multiplication property. And then as always, we can check our answer by plugging it back in the original and making sure it works. Okay, so let's do several examples here. So for the first one, it's negative 6x plus 5 equals 17. So first we have, so negative 6 times what? Plus 5 will give us 17. So first we need to use the addition property. We need to subtract 5 on both sides. And that's going to give us negative 6x equals 17 minus 5, which is 12. And then we need to divide by negative 6 on both sides. So we get 12 over negative 6, so x will be negative 2. So I'm going to check this one. I'm not going to check all of them. I'll leave that to you guys to check them if you want to. So negative 6x plus 5 equals 17, and we want to plug in a negative 2 to see if that works. So negative 6 times negative 2 plus 5 equals 17. That's 12 plus 5, which is 17, so we know that we did it correct. Okay, and then for the next one, we have 3x plus 2 equals 5x minus 8. So both sides are already simplified here, so we just want to choose what side we want to get the variable on. I'm just going to get the variables on the left. So I'm going to subtract 5x. That's going to give us 3x minus 5x is negative 2x. So we get negative 2x plus 2 equals negative 8. Next, we need to get this constant to the right-hand side, so we have to subtract 2 on both sides. So we get negative 2x equals negative 10. Divide both sides by negative 2. And then we get x equals positive 5. So once again, we could check it if we want, and we would see that this would check out. For C, we have 4 times k minus 3 minus k equals k minus 6. So first, we have to simplify both sides of the equation separately, so we're working with them independently. So it's going to be distributing. So we have to distribute that 4 to both terms. So that's going to be 4 times k minus 4 times 3 is 12, minus k equals k minus 6. So we have to combine like terms on the left. We have 4k minus k, which is 3k. So 3k minus 12 equals k minus 6. So let's get all of the variables on the left. So let's subtract k. So 3k minus k is 2k. 2k minus 12 equals negative 6. And let's add 12 to both sides. So we get 2k, I'm going to move up here a little bit. We get 2k equals, oops, I wrote 2 down here. 2k equals negative 6 plus 12, which is 6. Lastly, divide both sides by 2. We get k equals 3. So if we plugged in 3 here, we would also get, we know that we got the right answer. And then for D, so we have 8z minus 3 plus 2z equals 3z plus 1. So once again, we have to simplify this left-hand side of the equation. So this is essentially a -1 out here, so we have to distribute the negative to both terms. So it's going to be 8z minus 3 minus 2z equals 3z plus 1. Combine like terms on the left-hand side. 8z minus 2z is 6z. And let's get all the variables on the left. We're going to subtract 3z. And in one step here, I'm going to add this constant to the other side also. So 6z minus 3z is 3z. 1 plus 3 is 4. Divide both sides by 3. And we get z equals 4/3. Can leave it just like that. So a little bit messier, but that's okay. Okay, for the next one. So we have 4 times 4 minus 3x equals 32 minus 8 times x plus 2. So we're going to distribute. On the left-hand side, distribute the 4. So 16 minus 12x. On the right-hand side, distribute the -8. That's going to be minus 8x and then minus 16. So we distributed the 4 on the left, distributed the 8 on the right. So now we need to combine like terms on the right-hand side. So I'm not doing anything to the left. 32 minus 16 is 16. Okay, so I'm going to add 8x to both sides to get the variables on the left. And in one step, let's just subtract 16 again. So it actually cancels, the 16s cancel on both sides because we had subtracting 16 from one side and the other side so happened to have that same 16. So we get -12x plus 8, which will be -4x. On the right-hand side, everything canceled off. Since we're adding and subtracting and everything cancels, we get 0. So -4 times what equals 0? Clearly it's going to be 0, but divide both sides by 4. And we get x equals 0 over 4, which is just 0. Okay, so in all of those examples, we ended up getting one answer. There's also 2 other types of answers we can get. We can get infinitely many solutions, or we can get no solutions. So when we're solving linear equations, we either get no solutions, one solution, or infinitely many solutions. So let's do infinitely many next. So when a solution has infinitely many solutions, what's going to happen is that the variables, when we're trying to solve it, the variables are going to cancel off, and it will result in a true statement. You'll get something like 2 equals 2. So it'll be a number equals itself. No more variables, so we know that there's infinitely many solutions. This is called an identity equation. It means no matter what value of x we plug in, it'll always be true. So let's do some examples here. So we have 5x minus 15 equals 5x minus 3. 5 times x minus 3. So let's simplify that right-hand side by distributing the 5. So we get 5x minus 15. So it's probably pretty clear what's going to happen here. We have 5x minus 5 equals 5x minus 5. That's obviously true. Those are the same exact thing, so no matter what value of x we plug in, it's always going to work. But if you didn't recognize it yet, you can subtract 5x on both sides, and you can see that it actually cancels. Then we're left with -15 equals -15. You could add 15 to both sides here and get 0 equals 0, but this is enough to show that it's an identity equation. So this means there are infinitely many solutions. Okay, so that one has infinitely many solutions. And if you didn't believe me, you could plug in any number into x, and it'll always be true from the original. So let's see what happens when a linear equation has no solutions. So a linear equation can have no solutions when the variables cancel off. So once again, the variables are going to cancel, except this time it's going to result in a false statement. So this is what we call a contradiction statement, and the solution set would be the empty set. So the empty set meaning there's just no solutions. There's nothing that we could plug in that'll make it work. So let's do this example. So we have 2x plus 3 times x plus 1 equals 5x plus 4. So let's distribute the 3 on the left-hand side first. And then let's combine like terms on the left-hand side. So 2x plus 3x is 5x. So we get 5x plus 3 equals 5x plus 4. Let's say we wanted to subtract 5x on both sides. It would actually cancel on both sides. We'd end up with 3 equals 4. So 3 obviously does not equal 4. So I'm just going to put a little x. So this means there are no solutions. So the variables canceled off and we got a false statement. 3 does not equal 4. So no matter what value of x we plug in, this equation will never be true. Okay, so let's make them a little bit harder here. So we were dealing with integers so far. So let's do them with fractions. So to solve these with fractions, we kind of already done some with fractions where we just got common denominators and then solved them. There's also another way to do it. What we can do is we can multiply both sides of the equation by the LCD, which is the least common denominator, of every fraction in the equation. What this does is it cancels off every single denominator. So let's kind of see how that works here. So let's solve this linear equation. So 2/3 x minus 1/2 x equals negative 1/6 x minus 2. Okay, so we see we're dealing with fractions here. So let's multiply everything by the least common denominator. So the LCD here, it's the least common multiple of these denominators. Least common multiple of 3, 2, and 6, which will be 6. So I'm just going to rewrite this. We're going to multiply every single term by 6. The reason we can do that is because that just means we're multiplying both sides of the equation by the same thing. And now we can just think of it as distributing. So if we distribute on the left-hand side, 6 times 2/3. 6 times 2/3, I'm going to multiply that and make it 12/3 x. Then I'm going to distribute the 6 to the second term, 6 times negative 1/2. So it's going to be negative 6 over 2x. Distribute the 6 on the right-hand side of the equation. 6 times negative 1/6 is going to be negative 6 over 6 x, and then minus 6 times 2, 12. So I kind of did that the long way. Now we can simplify each fraction. 12 over 3 is 4. 6 over 2 is 3. Negative 6 over 6 is negative 1, so just negative x, and then minus that 12. So when you multiply by the least common denominator, every denominator cancels to just 1. So we're not dealing with fractions anymore, so it's a little bit nicer. Okay, so now to solve this, 4x minus 3x is just 1x. So x equals negative x minus 12. We need to get all the variables on one side, so let's add x to both sides. X plus x is 2x. 2x equals negative 12. Divide both sides by 2. So x equals negative 12 over 2, which is negative 6. As usual, you can go back and plug it in the original, make sure it works. Okay, let's do the next one. We have 1/3 times x plus 5 minus 3/5 times x plus 2 equals 1. So the LCD here is going to be between it's going to be the least common multiple of 3 and 5. So the least common denominator, denominators are 3 and 5. So the least common multiple of 3 and 5 is going to be 15. So if you have to list out the multiples of 3 and 5 separately and see what's the smallest one they have in common, that's fine. So we're going to multiply both sides by 15 here. So I'm going to just rewrite it so I have some room. So when we multiply both sides by 15, on the right-hand side, it's pretty obvious that we're going to end up with just a 15 because we have 1 times 15. On the left-hand side, we have to distribute. So it's going to be 15 times 1/3 x plus 5. What I'm going to do this time, I'm going to simplify it a little bit differently. I'm going to simplify it in one step. So I'm going to use the fact that 15 times 1/3 is 15 divided by 3, which is 5. And then for the next one, minus 3/5 times 15. 3/5 times 15, I'm going to do 15 divided by 5, which is 3. Multiply it by the other 3 and get 9. Okay, so hopefully you kind of followed along with that. If not, just do it the way I did it in the last one, where you multiply the fractions and then simplify afterwards. Just wanted to show kind of a shortcut if it makes sense, if it made sense to you. Okay, now we just solve this like we normally would because we have no more fractions, so it's a little bit easier. So we're going to distribute on the left-hand side. We're going to distribute the 5, distribute the negative 9. So it's 5x plus 25. Distribute the negative 9 minus 9x minus 18 equals 15. Combine like terms on the left. So we get 5x minus 9x. That gives us negative 4x. 25 minus 18, that gives us a 7. Equals 15. Subtract 7 on both sides now. And we get negative 4x equals 8. Divide both sides by negative 4. 8 divided by negative 4 is going to give us a negative 2. So negative 2 is our answer. We could go back up, plug that in if we want. We would get the, we'd find out that that is our actual answer. Okay, so let's do another one. Second last one. So we have x minus 3 all over 4 equals 5 over 14 minus x plus 5 over 7. So we need to find the LCD of between 4, 14, and 7 for those denominators. So let's actually, before I write what the LCD is, this one's a little bit more challenging because there's 3 of them. So multiples, I'll list out the multiples. Multiples of 4, that's going to be 4, 8, 12, 16, 20, 24, 28, and so on. The multiples of 7 are going to be 7, 14, 21, 28, and so on. And the multiples of 14 are 14, 28, and so on. So you just keep on repeatedly adding the number to itself over and over again, starting with the number. Okay, so now what we do is we look for the smallest one that they all have in common. The smallest one they have in common is going to be 28. So that means that our LCD, our least common denominator, is 28. So what we're going to do is I'm going to rewrite this. We're going to multiply both sides. So we're multiplying every single term by 28. So multiply the whole left-hand side by 28, the whole right-hand side by 28. So I'm going to simplify this one like I did the other one. Once again, if you don't like it, doing it this way, just do it the way I did it in the first one. So I'm going to do 28 on the left-hand side here. 28 divided by 4 is 7. So it's going to be 7 times x minus 3. So once again, the 7 came from just simplifying 28 divided by 4. On the right-hand side, 5 over 14 times 28. So remember, we have to distribute this, 28. 28 divided by 14 is 2. So that's going to be 5 times 2. And then 28 for the second term, 28 divided by 7 is going to be 4. And just don't forget parentheses around the x plus 5. So this number right here, this 7 came from the 28 divided by 4. This 2 came from the 28 divided by 14. And this 4 came from the 28 divided by 7. Okay, now we just simplify it. So on the left-hand side, I'm going to distribute the 7. That's 7x minus 21. On the right-hand side, 5 times 2 is 10. Distribute the negative 4. That's negative 4x minus 20. Combine like terms on the right-hand side. 10 minus 20 is negative 10. And let's get all the variables on the left. So I'm going to add 4x. And in one step here, let's just add this 21 to get the constants on the right-hand side. So 4 plus 7 is going to give us an 11. And then negative 10 plus 21 gives us 11 also. So 11x equals 11. 11 times what equals 11? Divide both sides by 11. We get x equals 11 over 11 is 1. Okay, so you can go back up, plug that in, and that would work. Okay, so let's do one more concept here. So let's solve some linear equations with decimals. So far we have already worked with decimals inside linear equations. We can just add and multiply and subtract and divide decimals like we normally do. We're going to do it a little bit differently here, and in my opinion, this is a little bit easier. So what we're going to do, once we realize we have decimals, we're going to multiply both sides by the smallest power of 10. What this does, it's going to change every decimal to an integer. So it's going to get rid of the decimals just like we got rid of the fractions in the previous ones. So let's see what I mean here. So we have 0.1t plus 0.05 times 20 minus t equals 0.09 times 20. So the smallest power of 10, we have one number to the tenths. 0.1 is in the tenths place. 0.05 is in the hundredths place. And 0.09 is also in the hundredths place. That means these ones are the smallest because they're in the hundredths. That means we multiply both sides by 100. If they were in the thousandths place, we would multiply both sides by 1,000. If they were in the tenths place, we'd multiply both sides by 10. we're just multiplying by whatever power of 10 will cancel off the decimals and make them integers. So I'm going to rewrite this for room's sake. 0.1t plus 0.05 times 20 minus t equals 0.09 times 20. So we're going to multiply both sides by 100. Probably looks a little messy. So let's see what happens. So on the left-hand side, we have to distribute, right? It's going to be, don't want that plus to look like a t. We have to distribute the 100 to both terms. 0.1 times 100, just remember when we're multiplying by a power of 10, we just move the decimal to the right, however many zeros is in that power of 10. So 100 has 2 zeros, so that means we move the decimal over 2 places for 0.1. That would make it 10. Same thing for 0.05, move it over 2 places, that would make it 5. And for 0.09, move it over 2 places, that would be 9. Okay, so now we have an equivalent equation, but now we're dealing with integers rather than decimals. So let's just solve it like we normally would. So on the left, we have to distribute the 5. So 10t plus 100 minus 5t. And on the right, we have to just multiply 9 times 20. So 9 times 20 is going to give us 180. And let's combine like terms on the left. So 10t minus 5t is 5t. Subtract 100 on both sides. So we end up getting 5t equals 80. Divide both sides by 5. And that's going to give us t equals, what does that end up being, 16? I believe that's 16. And we can go back up and we can check, make sure that's correct. And hopefully that is correct. Okay, I believe that's the last page. Yep, last page. So that's it for chapter 2.3.